This is SpaceTime, Series 25, Episode 34, full broadcast on the 21st of March 2022. Coming up on SpaceTime, how our galaxy, the Milky Way, is being changed by a supermassive black hole, the world's most powerful rocket rolls out onto the launch pad, and the James Webb Space Telescope obtains its first deep sky image. All that and more coming up on SpaceTime.
Welcome to Space Time with Stuart Gary.
A new study has shown how giant bubbles stretching some 36,000 light years above and below the Milky Way's galactic center are being produced by a feeding supermassive black hole. In 2020, the Rosetta X-ray Space Telescope captured its first images of two enormous bubbles. These Rosetta bubbles occupy roughly the same area of the sky as the so-called Fermi bubbles, which were discovered by NASA's Fermi Gamma Ray Space Telescope back in 2010. Now, a new study reported in the journal Amateur-astronomy suggests that these bubbles are all the result of jets of activity from Sagittarius A star, the supermassive black hole at the center of the galaxy. The study shows how the jets began spewing out material about 2.6 million years ago, and that the activity lasted for some 100,000 years. The results suggest that both the Rosetta and Fermi bubbles, together with a microwave fog or haze of charged particles roughly at the center of the galaxy, were all formed at the same time by the same jet of energy from the galaxy's central supermassive black hole as it was feeding. One of the study's authors, Mateusz Ruskowski, says the findings provide important aids to understanding how black holes interact with the galaxies they reside in. There are two competing models to explain these bubbles. The first suggests that the outflow is being driven by a nuclear starburst in which a star explodes as a supernova and expels material. The second model, which the team's findings support, suggests that these outflows are driven by energy being blown out of the black hole's accretion disk as material is crushed and ripped apart. Instead of passing beyond the event horizon, a sort of mathematical point of no return, below which nothing, not even light, can escape, this material is thrown back out into space by powerful magnetic field lines. These magnetic forces focus the material into two beams, shooting out perpendicular to the accretion disk. And because some of this material is being ejected back into space, black holes don't grow uncontrollably. But the energy coming from these events does displace material near the black hole, creating these large bubbles. And to describe them as large is an understatement. They're each around 36,000 light years tall. Now, by comparison, our solar system resides some 27,000 light years from the galactic center. The study's authors think that Rosetta bubbles are about twice the size of the Fermi bubbles and are being expanded by a wave of energy, a sort of shock wave, being pushed out by the Fermi bubbles. Astronomers are interested in the observations of these Rosetta bubbles in particular because they occur in our own galactic backyard, as opposed to similar objects in other galaxies or at extreme cosmological distance. Our proximity to these outflows means astronomers can collect an enormous amount of data. This data tells scientists about the amount of energy contained in the jet from the black hole, how long this energy was injected, and what material comprises the bubbles. Ruskowski says the new findings mean we can not only rule out the starburst model, but we can also fine-tune the parameters needed to develop a computer model of Sagittarius A star, the 4.3 million solar mass supermassive black hole which occupies the galactic center. The findings will allow astronomers to better constrain a number of things, such as how much energy was pumped in, what's inside these bubbles, and how long was injected in order to produce the bubbles. Right now, the data is suggesting that Rosetta bubbles were filled with cosmic rays, that is, high-energy particles including protons, electrons, and helium ions. And the Rosetta bubbles enclose the Fermi bubbles, the contents of which are unknown. But the new models can predict the amount of cosmic rays inside each of the structures. The energy injection from the black hole inflated the bubbles, and the energy itself was in the form of kinetic, thermal, and cosmic ray energy. Of these forms of energy, the Fermi mission could only detect the gamma ray signal coming from the cosmic rays. The study's lead author, Karen Yang from the National Tsinghua University in Taiwan, says her new simulations take into account the interaction between the cosmic rays and gas within the Milky Way itself. The cosmic rays ejected the gas out of the black hole, expanded and formed the Fermi bubbles that shine in gamma rays. But the same explosion pushes gas away from the galactic center and forms a shock wave that's being observed as the Rosetta bubbles. The new observations of the Rosetta bubbles has allowed Yang and colleagues to more accurately constrain the duration of the black hole's activity, its feeding frenzy which caused them, and that way better understand the past history of the galaxy. The researchers' model rules out the nuclear starburst theory because the typical duration of a nuclear starburst, and therefore the length of time into which the starburst would inject energy that forms the bubbles, would have to be around 10 million years. But the new active black hole model accurately predicts the relative sizes of the Rosetta X-ray bubbles and the Fermi gamma ray bubbles, provided the energy injection time is only about 1% of that. In other words, just 100,000 years. The simple fact is, injecting energy over 10 million years would produce bubbles with a completely different appearance. This is space-time. Still to come, the world's most powerful rocket rolls out onto the launch pad, and the James Webb Space Telescope obtains its first deep sky image. All that and more still to come on space-time. Well, after years of delays, the world's biggest and most powerful rocket, NASA's new Space Launch System, or SLS, has finally rolled out of the historic Vehicle Assembly Building at the Kennedy Space Center and undertaken the 11-hour, 6-and-a-half-kilometre journey to Space Launch Complex 39B at the Cape Canaveral Space Force Base in Florida. The massive 98-metre tall three-stage launch vehicle is the biggest rocket to travel aboard the giant crawler transporter since the Apollo 17 Saturn V mission, which carried the last men to walk on the lunar surface. And that was back in 1972, 50 years ago. In fact, the only other vehicles to undertake the same rollout from the Vehicle Assembly Building aboard the crawler transporters have been the space shuttle stacked on their external fuel tanks, which flew 135 orbital missions between 1981 and their premature retirement in mid-2011. The rollout will culminate with the SLS performing a fully fueled dress rehearsal next month of the long-awaited Artemis 1 mission. The Artemis 1 flight, which is now slated for no earlier than May, will carry an unmanned Orion capsule to the Moon and back. It'll test the performance of the SLS rocket and the Orion spacecraft and systems. During the mission, Orion will fly further than any other spacecraft built for humans has ever flown. It'll travel some 461,000 kilometres from Earth, thousands of kilometres beyond the Moon over the course of about 3 weeks. Orion will also stay in space longer than any other ship for astronauts has done without docking to a space station, and return home faster and hotter than ever before. The Artemis 1 mission will lead to the Artemis 2 flight in 2024. That will carry Orion's first human crew on a journey around the Moon and back, with the Artemis 3 mission then bringing people back to the lunar surface in 2025. This report from NASA TV.
3, 2, 1, 0. Ignition. Liftoff.
Artemis 1 will lift off from Launch Pad 39B at NASA's Kennedy Space Center in Florida with 8.8 million pounds of thrust, provided by the most powerful rocket in the world, our Space Launch System rocket, or SLS. The uncrewed flight will be the first integrated test of SLS, our new Orion spacecraft, and exploration ground systems at Kennedy. Artemis 1 will send Orion beyond the Moon, 280,000 miles from Earth, farther than any human spacecraft has ever flown.
This is not NASA doing this. This is the United States of America doing this program, the Artemis program, and there are companies all across our country that have a part in it, so there is kind of this wave of excitement being generated just by saying, we're going back to the Moon.
After the upper stage of the rocket separates from Orion, the upper stage will deploy small satellites over several days to perform science experiments and technology demonstrations. Orion will make its multi-day outbound trip to the Moon, propelled by a service module provided by the European Space Agency. Engineers will test Orion's systems on the way to the Moon. Then, Orion will fly about 60 miles above the lunar surface, using the Moon's gravity and engines on the service module to enter a lunar orbit. After about a month and a total distance of over 1 million miles, Orion will return home, faster and hotter than any spacecraft has before. A primary goal of Artemis 1, ensure Orion safely returns to Earth before we fly with humans. When we do, we'll build our capability for sustainable lunar exploration, preparing us for missions farther into the solar system.
Initially, what we'd like to do is start establishing a presence on the Moon. So we're going to establish going back there on a regular basis, and then we'll end up setting up Gateway, and we would launch to the Gateway, and from Gateway, land on the surface of the Moon.
We are there for, weeks, months on end. And there, we're going to be able to test out all the hardware and the habitats and the hatches and the suits and the rovers that'll allow us to prove out those technologies. The Moon will lead the way to Mars, and we should be there within the next couple of decades.
This is Space Time. Still to come, James Webb obtains its first deep sky image, and later in the science report, a new study claims the global COVID-19 death toll could be 3 times higher than official records show. All that and more still to come on Space Time. NASA says the optical performance of its new James Webb Space Telescope has not only met but exceeded the science parameters the observatory was built to achieve. The confirmation came following the completion of the fine phasing mirror alignment step of preparing the $10 billion space telescope for scientific research. The team found no critical issues and no measurable contamination or blockages to James Webb's optical path. With the fine phasing stage of the telescope's alignment now complete, it means mission managers have now fully aligned James Webb's primary imager, that's the near-infrared camera, to the observatory's mirrors. And the image produced, which you'll find on our Tumblr blog, is absolutely stunning. While the purpose of Webb's latest image was to focus on a bright star and then evaluate the alignment progress, Webb's optics are so sensitive that galaxies and other stars in the background could clearly be seen. The image released to the public was given a red color palette in order to optimize visual contrast. Interesting point, both Hubble and James Webb actually record light in black and white. They then use a series of filters to allow specific wavelengths of color through. The filtered images are individually colored by scientists and image processors, then combined into a final full image. The colors in space telescope imagery sometimes are designed to recreate the way our eyes see color. Other times, they're selected to highlight interesting features of an object, such as different elements in a nebula. NASA started the alignment process with James Webb months ago, with just 18 scattered dots and 18 reflections of the same star, one for each of Webb's 18 hexagonal beryllium primary mirror segments. The star chosen was HD 84406, a bright isolated star in the constellation Ursa Major. The dots were then rearranged, stacked and finally fine-tuned by making small adjustments to the motors at the back of each mirror. This process will continue towards the ultimate goal of having James Webb undertake its first science images towards the middle of the year. Over the next 6 weeks, mission managers will proceed through the remaining alignment steps before final science instrument preparations. This will involve further aligning the telescope's 6.5-meter primary mirror to include the near-infrared spectrograph, the mid-infrared instrument, the near-infrared imager, and the slitless spectrograph. In this phase of the process, an algorithm will evaluate the performance of each of the instruments and then calculate the final corrections needed to achieve a well-aligned telescope across all science instruments. Following this, Webb's final alignment step will begin, and the team will adjust any small residual positioning errors in the mirror segments. Ultimately, James Webb will not just supplement but eventually replace the Hubble Space Telescope, allowing astronomers to see further back through space-time than ever before, more than 13.4 billion years, towards the birth of the first stars and the formation of the very first galaxies. This report from NASA TV.
We got together and looked at the very first diffraction-limited images that came out of the Webb telescope. And what we collectively saw as a group is we have the highest resolution infrared images taken from space ever. So you think of it as a blob on a picture, but it is extremely high resolution. We have exceeded every expectation. The telescope has performed better than the models said it should. We've even achieved we talk about resolution and wavefront quality. We've done better in those regards than we thought we would do, and we're just thrilled to death. And to get there, we went through a process. Well, we did the segment identification, and then we formed the image array, and then once they were in the image array, we used this phase retrieval technology to position each of the mirror segments and the secondary mirror itself such that all the optical aberrations were effectively eliminated. We tilt the mirror segments to bring the light from each mirror so that it falls on top of each other at a common point in the middle of the detector. And we call that image stacking. And that concentrates all the light in a single place, but the images, the segments themselves are not cooperating. They're not working together at that point. They're all their own individual telescope. And the next phase in the process is something we call coarse phasing. And that's where we adjust, literally it's the piston, it's the up and down motion of the mirror segments relative to each other. We control the piston of the segments so that they all come together in creating a complete monolithic primary mirror. If you know exactly what the shape of that telescope is and you know exactly how the light is falling on your detector, it turns out that you can actually prove mathematically that that is enough information to tell you exactly what you need to do to that telescope to fix the alignment errors. And why do we know this? We know this because of something called a pupil imaging lens. And this allows us to take a picture of the primary mirror of the telescope. People have referred to it as a selfie. Right? Well, that's what it is, actually. But that's really important mathematically. Now, there's a catch, however. Just because you know a solution to something exists does not automatically give you that solution. And that is the difficult part. That's what we've spent 20 years working out. It's highly mathematical, uses something called Fourier analysis, but that's what we do, is we tease out those solutions and we find what we need to do to each optical element to achieve perfection. We then turn to a different way of doing phase retrieval across the entire aperture of the telescope at the same time. And for that, we're not going to take the telescope out of focus. Instead, we have some lenses that are in one of the science instruments that we use to automatically create a defocused image. And we look at these images and taken as a whole, then we can tell the last little bit of alignment errors that are in the telescope that we need to fix. And that's what we accomplished today. We analyze those images and we apply the corrections leading to the diffraction limit of the perfect performance of the telescope. So there's only one thing left to do, and that's to see how well the telescope is aligned in the other science instruments. And we'll check the alignment there, and if necessary, then we'll apply a solution that optimizes for the entire telescope. We then periodically measure the alignment of the telescope and make corrections as necessary. I cannot wait to see what it discovers.
And in that report from NASA TV, we heard from Wavefront Sensing and Controls scientist Scott Acton from the Space Telescope Science Institute. This is Space Time. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study claims that global COVID-19 deaths may be as much as 3 times higher than official records. The findings, reported in the Lancet Medical Journal, claim some 18.2 million people may have now died as a result of the pandemic during its first 2 years. While the official COVID-19 death toll was 5.9 million from the start of 2020 till the end of 2021, and now stands at just over 6 million since the virus first escaped from Wuhan, China, scientists compiled excess death statistics from around the world. That is, deaths that were unexpected compared to average death tolls before the pandemic. Using modelling to plug gaps in the data, the researchers estimate excess deaths of 18.2 million people, with the highest death rates occurring in Latin America, Eastern Europe and southern sub-Saharan Africa. Australia, they say, is one of just a handful of countries that appear to have had slightly fewer deaths than usual over the past 2 years, with 38 fewer deaths per 100,000 people before the end of 2021. Sea ice around Antarctica has now shrunk to a new record low level. A report in the journal Nature has found that sea ice reached a minimum extent of 1.92 million square kilometres, which was recorded on February the 25th. And that's some 190,000 square kilometres less than the previous record low in 2017. Scientists say that the low was partially caused by strong winds pushing ice into warmer waters, where it quickly melted. Researchers are attributing the extreme to natural variability, but add that over the long term, climate change will result in declining sea ice across the polar region. A new study claims the giant predator dinosaur Tyrannosaurus rex might actually have been 3 separate species rather than one. Paleontologists re-examined the remains of 37 T-Rex specimens. They found physical differences in the femur, as well as dental structure differences, with specimens showing up with either 1 or 2 slender incisor teeth on each side of the front of the jaw. A report in the journal Nature Evolutionary Biology claims that the reanalysis suggests that the mighty tyrant lizard king should actually be recategorized into 3 distinct species. The large carnivorous theropod, which roamed the Earth some 66 million years ago, could reach lengths of 12.4 metres, more than 40 feet, and weigh as much as 14 tons. The researchers suggest that the larger specimens should now be reattributed to a new species which they're calling Tyrannosaurus imperator, the tyrant lizard emperor, and the smaller, more slender specimens should be reattributed to a different species which they're calling Tyrannosaurus regina, or the tyrant lizard queen. However, paleontologists acknowledge that they can't rule out that these differences in the bones could simply be due to extreme individual differences or a typical sexual dimorphism rather than separate species. A new report by the CIA claims Havana Syndrome is nothing more than anxiety, mass suggestion, and normal medical conditions that can happen to anyone. The syndrome describes a set of medical symptoms experienced by United States and Canadian embassy staff in Cuba and later in China between 2016 and 2018. Victims typically reported first hearing strange, grating noises that seemed to be coming from just one specific direction. And that just got worse, eventually experiencing it as if it was a pressure or vibration, ultimately triggering headaches, dizziness, hearing loss, memory loss, and nausea. Subsequent medical examinations of victims showed they had injuries which were consistent with concussion. Now, follow-up investigations, including discovery of recordings undertaken during these events, picked up unusual infrasound waves. Infrasound involves sounds lower than 20 Hz, which are inaudible to humans. The incident sparked speculation that these were in fact attacks targeting diplomats using some kind of new acoustic weapon. However, even at the start, there were others claiming it's nothing more than some sort of mass hysteria illness, or possibly exposure to neurotoxins from earlier fumigation works, feedback from faulty secret listening devices planted by enemy operatives, or even the chirp of either the Indies short-tailed cricket or the Jamaican field cricket. And the thing could have been dismissed there. But where this all gets interesting is that Russia had previously undertaken acoustic attacks against the United States Embassy in Moscow. The problem is those incidents involve pulsed radiofrequency microwave radiation, which is ultrasound, not infrasound, and involve frequencies over 20,000 Hz, which are inaudible to humans. But it doesn't end there. Recently, the Chinese Academy of Sciences confirmed that the People's Liberation Army are deploying new sonic guns that use focused infrasound waves designed to cause extreme discomfort and physical distress to people by generating vibrations in the eardrums, eyeballs, stomach, liver, and brain. Infrasound's effects on the human inner ear includes vertigo, balance, intolerable sensations, incapacitation, disorientation, nausea, vomiting, bowel spasms, and resonances in inner organs such as the heart. And don't just think of it all as something that happens overseas. Last month, Australian Capital Territory Police were accused of deploying sonic weapons known as long-range acoustic devices against anti-mandate protesters in Canberra. Police claim they were only being used to broadcast messages and alarms at high volumes. However, the problem is their use for this function is negated, as patrol cars are already equipped with public address systems and whaler, hee-haw and yelp sirens, which therefore raises concerns about the honesty of the police. Protesters following the rally reported feeling nauseous and sick from the effects of sonic weapons. It's also claimed that New South Wales Police deployed similar weapons during the Black Lives Matter protest in Sydney in 2020. As to our original CIA report, well, it claims that most of the 1,000 or so Havana Syndrome cases it's looked at have normal environmental explanations and include undiagnosed medical conditions and stress, not the result of an international campaign by Russia or some other foreign power. Tim Mendham from Australian Skeptics says the CIA is continuing to investigate about 24 cases that are still unexplained. But he stresses that shouldn't be taken as suggested there's some sinister plot against American diplomats and intelligence officers.
A number of years ago, that a lot of the workers in an American embassy in Havana, appropriately being Havana Syndrome, suddenly came down feeling very ill. Various symptoms, headaches, dizziness. Some of them, people sort of getting quite seriously ill. Some of them saying they can never work again because of the impact of goodness knows what. And a lot of people were suggesting it was a microwave weapon being used from the Russian embassy or some other embassy aiming it towards the Americans to put them off. Now, these were a lot of people, not just one or two. Someone said it's up to 1,000. I don't know how many people are in this American embassy in Cuba, but never mind. They were anxious. What this report in a particular psychology thing was that it's a psychogenic syndrome, that it does manifest itself physically, right? But some of those physical things are a bit susceptible to psychosomatic explanations: headaches, nausea, dizziness, fatigue, difficulty concentrating, disorientation, forgetfulness, confusion, tinnitus, insomnia, head pressure, and ear pain. Now, they are pretty subjective, most of them, complaints. There was initial investigations by psychologists and things who suggested that these complaints are pretty common, that most of us would have had them at one time or another, perhaps all the time. But the CIA then followed up, with a CIA being interested in such things, followed up and found much the same thing. He said they say it's not hoaxing, it's not that these people are sort of weird and sort of different. They say that these are common elements of probably, we wouldn't say mass hysteria, but certainly in groups of people they encourage each other to have, unconsciously or whatever, to have symptoms of concern. If a group starts being anxious and worried and claiming of headaches, a lot of other people would do the same thing. It happens a lot in schools, quite frankly, where you get one group of people starts getting a illness of some sort and the rest follow suit. It happens with UFO reports, it happens with ghosts, it happens with all sorts of things. Now, I'm not going to call it mass hysteria, but it's certainly sort of mass illness and mass neurosis or something like that. But they're saying it's real physical manifestations, but I would suggest that these physical manifestations are very prone to subjective manifestation. We call that a psychogenic, is a physical condition caused by a mental situation. But anyway, they were blaming microwaves on it, and people have been blaming these things for a while. Microwaves. People have been suggesting at recent anti-vaccination protests in Canberra, a group of people saying they were getting headaches and that sort of stuff. And they were blaming police using long-range acoustic devices, LRAD, to actually sort of affect their brains with subsonic sounds to sort of disorientate their atoms, etc. LRAD exists. It's a real thing. It's normally used as a loud hailer as much as anything, but also to put out loud screeching noises, to put out not quite as much fun as what they were using in the New Zealand Parliament, where they were playing Barry Manilow. Or also in Havana, I think it was, when they got rid of, who was it, the cocaine warlord leader who was hiding out in one building. They kept playing AC/DC till he couldn't stand it anymore. But these LRAD things, hear them doing it, right? Whether it's a loud hailer, obviously that's someone just yelling at you, or loud screeching noises, you can hear them. The suggestion that there's subsonic or sort of, infrasound, as some people have described it, is dodgy, and the Havana Syndrome was apparently like that because no one could hear a sound.
China have started using focused energy weapons against Indian forces on their joint border in the Himalayas.
So how do they work?
They literally started cooking your molecules from the inside. So you sort of became very uncomfortable very quickly and moved away.
Okay, well, that's what some people are saying the L rate is directed energy.
Yeah.
So whether it's a subsonic thing or something you could hear, I don't know. I'm trying to think. I didn't know that about China, I must admit.
Yeah,
So.
yeah, that was a professor who was one of the Beijing mouthpieces.
Well, the thing is they're suggesting is that there's nothing there at all, and meanwhile they're experimenting on it.
Well, they probably are. They're probably testing it themselves.
America, the CIA will experiment on everything, as is their want, just in case something works out.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.